Alright guys, today we're taking a look at multiplying trinomials that don't have a first term of x squared but have a first term of ax squared, so there's a number actually before there. So first question to ask is, what kind of polynomials would you multiply to create the trinomial that you see above? Well, hopefully what you're realizing is that when we started factoring, we were only dealing with polynomials that came from stuff like x plus 2 times x plus 3. It's really all we were doing. They both had to start with x. Now what we're doing is we're saying, okay, there's got to be a number before at least one of them or maybe both of them. Okay? So, here's what we're going to do. We're going to multiply each of these binomials times each other forward. Okay, but I'm going to use the method where I write it out as a double distributive property. This is a great way to handle things when if you've gotten a few wrong answers in a row, or you're just not quite getting the multiplication. This is a very safe way to do it because we've done these problems a lot. Now the reason I'm showing the work in this way is because what we're going to be able to do, this first factoring method, it's a very straightforward method, and it's one in which you can actually manage this, and you pretty much have all the tools already at your disposal to be able to do this. Okay? And it's basically just going to be working this process backwards. Why don't you guys do B, pause, and then come back. Okay, welcome back. I'm going to show the work now here. Okay? And what we're going to look at then is, how do we step this problem backward and get back to the original problem. Okay, so what we're going to see is, here we go, our final answer here is 6x squared plus 5x minus 1. So remember then, factoring is, say we started with this, how would we get back to that original expression? Or if we started with this, how do we get back to that original expression? So here's what I'm going to do. I'm actually just going to take this first one and I'm physically just going to write the problem backwards from last step to first step. And what we're going to try to do is we're going to see if we can't figure out how each of those steps could have been figured out, could have been determined. Okay? So, looking at this first one, the first step, I guess, that we should be doing if we're factoring is to get from here to here, which basically involves changing the 23x into 15x and 8x. Well, I guess we can see that it makes sense that it's okay for us to do that, but I don't know that we necessarily see why that's the case. Then we have to do this, and we actually know how to do this step already. So imagine that I told you to factor out the GCF from these two terms and factor out the GCF from those two terms, very similar to what we did on our last test. Well, you'd say the GCF here was 3x, and this is what you'd have left. The GCF here is 2, and that's what you'd have left. Okay? So, then the last step is our original expression. Oops. That was supposed to be a plus, my bad. And I think we can kind of see where that came from. Because these two parentheses are exactly the same and we're multiplying two different things by it, we can basically say, oh, this is like the first step in the distributive property. So we must have been distributing 3x and 2, which we put here and here, to 4x plus 5. This only works if you get two parentheses that are exactly the same. So the part that we now need to figure out is, how in the world did we know that we had to split up the 23 into 15 and 8 as opposed to 20 and 3 or 21 and 2 or 23 and 0, all sorts of things we could have split it up into. That's where splitting the middle term comes into play. We actually have a method that we can use to help us figure out how to get those two specific numbers. So here's what you do. When you're sitting at your original problem, This is the method for figuring out those two numbers of 15 and 8. you take your first number and your last number, your first two coefficients, and you multiply them together. And then you look for two numbers that multiply to that and add to your x coefficient. They obviously have to add to your x coefficient, because if they don't, well, guess what? Then you can't split the middle term up using those two numbers, because you'd get a new expression, one that didn't match the original. Okay? So if I didn't already know this was 15 and 8, what I would probably do is I'd start writing out some different numbers that multiplied to 120, like 120 and 1, or 2 and 60, or 3 and 40. See how none of these still add to 23 yet, and we're not there yet? We could do 4 and 30. We're not quite there yet. 5 and 24. We're getting warmer. Those add to 29. And then eventually, I'm just going to skip ahead. We would get to 8 and 15, which add to 23. Okay? Do you have to write out all these numbers? No, absolutely not. If you can just figure it out, that's fine. I sometimes do the work on the calculator. The calculator really helps out a lot there and can help me figure things out, so that's a possibility too. Then, once you get those two numbers, you use them to split the middle term into two terms. That's why this process is called splitting the middle term. And then the rest is all stuff you know how to do already. Take the GCF of the first two terms and the last two terms. Okay? And then, so that would be, oops, not 4, 3x, and we're left with 4x plus 5, and 2, and we're left with 4x plus 5. And then assuming you got these parentheses to match, that means you just figured out our two parentheses. One of our two parentheses had to be 4x plus 5, and the other one we must have been distributing or multiplying 3x plus 2. It's really that simple. Okay, so let's take a look at then some actual practice problems. Okay, so now we don't actually know what the answer is, so that might potentially make things a little bit more challenging. Okay, I'll walk you through the first one, and then I'm going to have you try the next 4 on your own, and I will come back in and show the work. So, first thing I do, I figure out my target number. My target number is 10, the first and the last coefficients. So I need to find two numbers that multiply to 10 and add to 7. Well, my only options are 10 and 1 or 5 and 2. I'm going to go ahead and go with 5 and 2 because those are the ones that add to 7. Now the question is, does it matter whether you do plus 5x plus 2x or plus 2x plus 5x? Like, does the order matter there? And the answer is simply no. The order does not at all matter there. You could put them in any order. I'm in fact going to use 5 and 2 here, that order, even though the other order would actually make things, I think, a little bit easier, but I'm going to do it for a specific reason. So, GCF, GCF. GCF here is x. I'm left with 2x plus 5. This is now a very similar problem to one that we had on our test. It doesn't seem like it has a GCF, but it does. GCF is 1, and you do have to write that here. Otherwise, it'll kind of make that last step, I think, a little bit messy. So my parentheses matched. So that was my second set of parentheses. And I must have been multiplying by x plus 1. Woohoo! And again, we could go back and check our work. X times 2x is 2x squared. I get a 5x and a 2x. That makes 7x. And I get a 5 at the end. Works great. Okay, try the next 4. The only hint that I need to really give you is that anytime you see a subtraction sign, that means you do have to make that number a negative. That includes when you're doing the multiplying and the other stuff. So just make sure you do that. Try those 4, pause, and then come back. Okay, I'm assuming you're back and that you've already done all of those problems. So here's what we're looking at. Here we're looking for two numbers that multiply to 10 and add to 11. 2 times 5 is 10. Then we're looking for numbers that add to 11. It's 10 and 1. Split the middle term. 2x squared plus 10x plus, you could write 1x or just x, plus 5. GCF, 2x for the first one. And 1 again for the second one. I think it's nicer if you just take that out. We do have parentheses that match, so that's my second set. Whatever's left is my first set. I could check my answer, but that definitely works. Okay. Last, here we go. Looking for numbers that multiply to -6, because we got a -2 there, and add to 5. It's important that that's a -6. Okay, so I can't use 3 and 2. That can be something that's really confusing here. I can't use 3 and 2. Okay, I gotta use +6 and -1, because one of them's got to be negative. 3 and 2 do make 5, but they don't make not when one of them's positive and one of them's negative. Okay, so split my middle term. 3x squared plus 6x minus x minus 2. GCF here is 3x. Here, if I just took out a 1, that would be all right, but that's not going to be super helpful. Okay, I got to take out a -1. If I don't take out a -1, those parentheses won't match. Now they do. I get 3x minus 1 times x plus 2. Video is getting a little bit long, so I'm going to let you talk about the last two together in your groups. But what I will do is I will reveal what the answers are, because I have a way that I can quickly do it in my head, which I am going to talk to you a little bit about later in the week. So this one's going to be 3x, and x goes here, and minus 1 plus 2. Yep. Okay, so this is what you should have gotten to the answer for this one. And this one, you should have gotten a -4 over here and a +1 over here. Okay, so those are the answers to the last two. If you need to discuss the work in your groups a little bit. Sorry for the long video. It's an introductory lesson to this. We're going to have 2 more lessons on this where I show you 2 different methods. One is somewhat similar to this one, and the other is potentially a little bit faster, but not as direct of a method. That's it for today.